Hi, I am Bhagilakshmi, Department of Mathematics, SNS College of Technology. Today we are going to discuss about the eigenvalue problems arising from population models, that is Leslie model. What is the Leslie matrix? Method for representing dynamics of age or size structured populations. Combines population processes, births and deaths into a single model. Generally applied to populations with annual breeding cycle. By convention, we use only female part of populations. So based on this, we can discuss one problem. So the Leslie model describes age-specified population growth. So as this one, as we can discuss, let the oldest age attained by the females in some animal population be 6 years. Divide the population into 3 age classes of 2 years each. Let the Leslie matrix be L equal to 0, 2.3, 0.4 and 0.6, 0, 0, 0.3, 0, 0. So this is the given matrix. So the question is continued. So our first question is, what is the number of females in each class after 2 years, 6 years, of 2 years, 4 years, 6 years, if each class is initially consists of 500 females. Each class is 500 females. The second one is, for what initial distribution will the number of females in each class change by the same proportion, and what is the rate of change? So from these two we can calculate now. So for the first question we can choose the given matrix. What is our given matrix is L is given, that is the Leslie matrix is given, and initially each females is considered as 500. So the initial value we can choose 500, 500, 500. After 2 years we want to calculate. So after 2 years the number of females in each class is given by x2 equal to L x naught. So L into L matrix into x naught matrix. So first row with first column, first second row with first column, third row with first column. So if you multiply all those and we get the column matrix. So this way we got the after 2 years values. Next, same thing we proceed for the 4 years and 6 years. So after 4 years the number of females in each class is given by. So that is 4 years means x4, which is equal to already known value is for this last is x2. So L into x2 multiply these two matrix and you will get 750, 810, 90 as the fourth after 4 years. Next we move on to the 6 years. Same procedure we proceed for the same. After 6 years, the number of females in each class, x6 equal to Lx4. So, Leslie matrix and this x4 matrix. Multiplying these two, we got the answer. So, this is the way we calculated the first case, and then we move on to the second case. So for the second case, the rate of change we want to calculate and the growth level also we want to calculate. So for this we are taking the Leslie matrix, and then from the it is a 3 by 3 matrix, so we are writing the characteristic equation. So for after this we are calculating this C1 and C2 and C3. So here the C1 is 0 and C2 we got the adding the minus, sum of the minus, we got the minus 1.38. And calculating the C3 value, the determinant of A. So the determinant of A is, the value is 0.073. So if we calculated all these three values, we can substitute in the equation. In this equation, all the values are substituted, and also using calculator calculate the lambda values. Here 2 lambda values are in negative terms. For the growth we consider only the positive roots. So the final conclusion for this lambda is lambda equal to 1.2. Next we move on to the eigenvector. So eigenvector basic formula we know, that is A minus lambda I into x equal to 0. Instead of here the given matrix is in terms of Leslie model, so we can choose instead of A as L. So L minus lambda I is in the diagonal alone will come other minus lambda. So into x value and equal to 0 matrix. Here the only one lambda value, so directly we can substitute in this equation lambda equal to 1.2 instead of this lambda value. Okay, and then here taking first and second rows, so if we multiply first in ABC, that is these two values we get the first cross minus second cross. From this we are getting a value of x1, and next to 2 cross we get the value of x2, and next to 2 cross we get the value of x3. So this way we are getting the values of x1, x2, x3. Multiplying all those values, easily we got an answer for x1, x2 and x3. But before that we want to consider here 0.48, 0.424 and 0.06. All the values are having the two decimal places, so we can conclude based on this, and each and every value is divisible by 6. So the final conclusion for x1 is 8. In 6 table 48 is 8 times, and 6 table 24 is 4 times, and x3 is 1 time. So this way we can conclude. So therefore the x1 value we got, x1 is 4 and x2 is x1 is 8 and x2 is 4 and x3 is 1. In each case we got the answer. So in each female calculations we got 8x plus 4x plus 1x, which is equal to, so 500 plus 500 plus 500 we initially choose. So the conclusion is 1500. From this we can calculate the x value. X value is 115.4. So in each case separate value we can calculate it. So first class one, just 8 into this x value. So 8 into x means 8 into 1, 15.4. If we multiply 923. So the approximate value only we are taking. So this way 4x equal to 461 point some decimal value you get. So if we concluded approximate value, if we concluded this one means 462 will get. Likewise 1x also 115.4 we can approximately we can write it as 115. So from this in each class we got the final answer. Same thing, the growth rate is we are getting from the lambda equal to 1.2 per 3 years. Thank you.